We now have a slightly more complex circuit, but no need to worry about that. Just pay attention to a couple of rules and the rest is easy. As shown in diagram A, we have a total of 6 resistors in the mixed circuit. Their values and supply voltage are known, but we still have a lot to calculate. So let's go. The goal is to first determine the total resistance of the circuit. During the calculation of the total resistance, the diagram will become simpler. Between nodes 2 and 3, 4 are resistors R3 and R4. Since theirs are at the same potential, it means they are in parallel. This means they have a common voltage but the currents are different. Particularly interesting is the situation in nodes 3 and 4 where both nodes are at the same potential but the currents are completely different. We'll get to that later. The next thing we can calculate is the common resistance 5,6. Between nodes 1 and 4, the resistors are in series. This is easy to recognize because the end of the first resistor is connected to the second. We also have a common current through both resistors that will induce a separate voltage on each of them. Now we can simplify the diagram. We see from diagram B, that resistors R2 and R3, 4 are in series and we calculate it in the same way as R5, 6. We are now close to a final solution. From diagram C, we see that resistors R2, 3, 4 and R5, 6 are in a parallel circuit and we calculate it. And finally we can calculate the total resistance. Resistor R1 is in series with resistor R2, 3, 4, 5, 6, so we calculate it. Now we are calculating the current I, and everything will become much more interesting. We return to diagram D, where we see that the currents I1 and I2, 3, 4, 5, 6 are actually the same as the current I. This means that we can also immediately calculate the voltages V1 and V2, 3, 4, 5, 6. We take another step back to diagram C. Note that the current I is divided in node 1 by the current I2, 3, 4, which we immediately calculate. And on current I5, 6. Since we know the common voltage V1, 2, 3, 4, 5, 6, using Ohm's law, it is easy to calculate them. We still check if we have calculated the currents well and move on to calculating the voltages V5 and V6 as follows. We now return to diagram B, and calculate the voltages V2 and V3, 4 in the same way as we have already calculated V5 and V6. The only difference is that we use I2, 3, 4 current to calculate. Finally, we only calculate the currents I3 and I4. As you can see, there is also I456 current, but why? Due to the difference between nodes 2 and 3 4. In node 2, the terminals of resistors R3 and R4 are directly connected to the same node, while between nodes they are not. This means that their connectors are remote and connected by a wire. Pay attention to this because it can be very useful in understanding complex circuits. Let's just check if we calculated everything well and super. This small difference is due to the rounding of decimal numbers. So everything is okay. Comment, suggest, and subscribe so you don't miss more interesting upcoming videos. Also try to do this example yourself with modified values.